You have. You're doing a fabulous job. I've been impressed with how
I
they
get
do.
done fast.
All right, you're not on the bus. Karina's not on the bus. What about you?
He's coming.
No bus. Vontae's no bus. I get.
We was on our
I know we were on a roll. I got Diamond, I got Jada, and I got Lolly, and then I get 4 of you who are talking.
It evens out.
It evens out. No, it doesn't. It still sucks. I got 4 of them super referral forms here.
Or you could just say,
It goes against everything I believe not to. So, yeah. Now the problem is, can I remember? Yeah.
oh yes. I don't watch the video, so I'm sick of
Now, theoretically, y'all have detention Monday. I strongly suspect it will not be Monday. I would assume it would be the day you would come back.
If you like me, at first I was in the name clothes, but I had to switch. I was bed and had to start saying something else, so I just need some. Yeah, on the quiz today.
Same stuff as on homework last night.
So basically, it's on the opening.
Oh, yeah.
They're alcohol. They go up.
You know, no.
Yeah,
Stress thing, analysis thing.
I don't understand that. Oh, we did it yesterday, right? Okay, good. You don't make sense. Track segments are 3 options.
Huh? Track, I mean, track. Yes. So verse 32.
Yes.
Good.
All right, I've got 8:29. That should have been enough time to work 2 questions. So if we look at the first one, how do we find density? If that's on the quiz today, what do we do? Okay, so D equals MP over RT. That's a little wide there. That is not what I want. Boy. All right. Adding 1,000. All right, so D equals MP over RT. All right, so what do I know? Temperature is? All right, I heard R is? Okay, I know. Okay. And? Okay, how'd you get that? For anybody who doesn't know. Okay, so what's the formula that y'all are adding up? Because that's how they would know. Okay, so sulfur trioxide's formula is? Okay, so sulfur is S. Tri means O3. Okay, that's how they got that. So S has 1, O has 3 times 32 times 16 for a grand total of 80. That's how they got it, in case you didn't. Okay? Angel, of course, you have detention unless you run a late bus. Did you have a late bus? All right, I fill out the form in a little bit. You have detention supposedly Monday, but I sincerely doubt we'll be here Monday, so I assume the next day that we're here. Okay? So 80 times 1 over R times temperature. So what did y'all get when you calculated that? 3.56. You can drop it at 3.5 if you prefer, and then grams over liters. So what y'all got? Yay. All right, so the next one, molar mass.
Wait, why is there grams?
Why is there what?
Why is it grams?
Because that's the unit. What'd you put? No, it's grams over liters. It's a mass over a volume. Yes.
Okay, so the molar mass, what does it be, A and B, U, or grams over liters?
No, grams over liters is density. Grams over moles is molar mass.
Okay.
Wait, and you also put AM.
All right, this one for molar mass can be grams. Whoops, that looks terrible. Grams over moles, U, or AMU. That's molar mass. Okay. For density has to be grams over liters. Okay. So when I finish this one, I'll put one of those units on it.
Okay.
Okay. All right. So to do molar mass, big M equals little m R T P V. What do I know? Okay. Got it?
T.
T is what?
45.
Okay.
Volume.
455 ml. Okay.
Pressure.
106.7 kPa. Okay.
Change the
Yep, we will. And what's the last one?
5.89.
Okay, 5.89 grams. So the only one that's okay up there is R and what else? And mass. Those are the only two that are in the right units. Everything else has to be changed. Okay, so. $45 plus 273 is 318. 106.7 divide 101.325 is 1.05. And then 0.5458 for the volume. All right, anybody have issues with those conversions? Okay, so last thing we have is big M equals M, which is 5.89, R, which is 0.0821, temperature, which is 318, over P, which is 1.05, times volume, which is 0.5458. 4 looks a little jacked up there. Big M equals, what'd y'all get? 268.3. And this one you can put U, AMU, or grams per mole on it. Questions? Anybody have a question?
The volume has to be in liters.
The volume has to be in liters. Yes.
So it's R.
Because there's an R. That's correct. Question?
Only thing you have to do to change it is divide it by 1,000.
Yes?
the unit for R.
Oh, yeah.
It's liters times
Atmospheres,
atmosphere divided by.
moles times Kelvin. It's on the blue sheet.
It is?
That's
Oh,
that's a,
thanks.
It's on the blue
we
sheet.
ever have to plug anything in that?
No.
It's on the blue sheet. You can also find it by plugging it into PV equals on RT. All right. From there, homework. If you want answers to homework, we're down to how many minutes we got? 5. But in the 5 we have remaining. All right, number 1. So you checked these yesterday, or asked me and I told you. Number 1 should have an answer of 1.25 grams per liter. Number 2, 78.8 grams per mole. Number 3, 0.828 atmospheres. Number 4, 2.22 grams. Then we jump to what number? 9 would be 0.65 moles. 10 is going to have a lot of play, okay? Because, a lot of play in the answer. There's going to be a big differential because it's a big answer. You're going to have a lot of, like when Caroline asked, would 10 be a big enough discrepancy? And I said no. Okay, my answer is 2,647. All right, your answer might be significantly different than that based on how you rounded, but you should be in the 2,600 range. Okay, anybody not in that range? What'd you have? You didn't remember it's diatomic because yours is exactly half. Say what? What? Yeah. And number 12 should be 50.9 grams per mole. All right. Number 10 asks you to find the temperature of oxygen. So you have, what formula did you use? Almaja, what formula did you use? You didn't do it? Which one do you want to use?
PV over T equals PP, P1, P.
Okay, dear. How many temperatures and how many pressures do you have in that question? Do you have 2 pressures and 2 volumes or 2 temperatures?
No.
Then you cannot use the one you just yelled out. Okay, you can't use a P1 V1 over T1 if there's only one of each of those things. Okay, so that's how you eliminate some of the things you just yelled out. All right, so when you look at question 10, it says, what is the temperature? So we're solving for T. We know R is 0.0. Let me split that out a little bit. We know we're looking for T. R is 0.0821. All right. We have 10 liters. So that's going to be our volume. Our pressure is 3.5 atmospheres. So that's going there. And we have grams. Can I put grams in for a moles? No. So I'm going to change 5.16 grams. And this is what Karina did wrong. She forgot oxygen is what? Diatomic. So instead of using 16, she's got to use 32. So 5.16 divide 32, and I got 0.161. Now, I put 0.161 there when I calculated. All right. If you put 0.16 or you round to 0.2, that's going to change your answer significantly when you calculate. That's why I said there'd be more play in the answer. So we're going to divide by 0.161, 0.0821. So we're going to divide here by 0.161 and 0.0821. And that'll give you your temperature. I got, what did I say? 2,647 Kelvin.
I don't think I did that.
Okay, did you use big M?
I did, big M mass.
You can. Some of these can be worked with a different formula. That's why I asked Almaja which formula she used. It's okay. That's why I said yesterday some of my keys are worked in 2 different formulas because 2 different formulas will work with a lot of them.
What other formula we have to do?
Big M. You would have said 32 equals, what was that mass again? 5.16, 0.0821 for R. You don't know temperature. Pressure is, what was the pressure? 3.5, and volume is 10. And then solved. Cross multiply and divide.
Yeah, that's a lot of work.
Well, it's not really that much more. You just got to cross multiply and divide. It's not bad. Oh, it's the cross multiplying. Okay. Anybody else? Thank you, sir.
You're welcome.
All right, so we're good? Fabulous. It's 8:40. You need a blue chart if you would like it with your numbers, a periodic table, calculator, and something to write with. Oh, are you taking things or backing it up?
Oh, no.
Tell us if this has a lot of stuff like it's just.
It's only the 3 that we did yesterday. It's just like the homework. I mean, but the 3 that we did yesterday are mixed up.
Yeah.
Yeah, but I didn't put like P1, V1
Yeah.
on it. No. No, I didn't do that.
So we can solve this using any of the equations.
Mm-hmm. Yep. I told you my keys are done in more than one formula. Plus, if you do it a different way, I'm sure I can figure it out. You better pull your head up out of the sand.
Just thinking. Go all that. Charlotte, it's what it's today.
We're not in school, probably through Wednesday.
Yeah.
You should have. You should have.
So she said.
Yeah.
Okay.
Those of you working have about 5 minutes.
All right, has everybody had a chance to finish?
No.
I did.
And more y'all have? I give y'all about 3 minutes. In this pace, y'all will not finish the test. All right, finish your purpose to the front. If you're still working, keep working, but we're going on now. All right, plunge notes. We're going to do volume ratios. And then we're going to do volume mass stoichiometry. We've got somewhere in the ballpark of 40 minutes. do these two things. One we started yesterday and one we're gonna work on today. Now, I will attach to the website a video for one of them because we will probably not get it fully finished today. Now, your job during the snow is to watch if you don't understand everything from what we do today. Now, truth be told, those of you who are already struggling are probably not going to be okay with what we've got done by the time the bell rings today. So what do you need to do between now and when you return? Watch the video and practice the word problems. We will test within 1 day of returning from the snowstorm. This material is not that difficult. Some of what y'all are doing is you're not making much effort. I can't fix that. So there, my desk here. Okay? Yes. Yeah. So there, my desk. You got to put in a little effort. Okay? Now, if I was a betting woman, I'll be shocked if I see y'all before Thursday of next week. Okay? I think it's conceivable if we get what they're calling for. I may not see you at all next week. Okay? Huh?
I'll die.
Just tell me. It's possible. Now, I'm hoping for the lighter end of the weather. Streets to be plowed, salt to be out, dust to be here. But the reality is, I don't know what's going to happen. I don't know when we're going to make up the time. Yes. So, here's a sample to go with volume-volume ratio. You have one. I wouldn't write more than this second one. You will have more for homework. You're in an honors class. I expect you to put forth more effort than some of you are putting forth. The last 2 days, I've graded half a class at 0 homework when I've checked homework. That says to me some of you are doing absolutely nothing outside of class. We will test within 1 day of return. The 2 problems we're working on today account for approximately 30 points of the 100 points on the test. They're not all of it, but they are certainly enough to cause you to have a low grade. So, yesterday, we began the part of the unit that goes with what is known as stoichiometry again. We brought back in our chemical reactions. So that's where we're going to spend our focus today. Everything you did on today's quiz, did it have a balanced equation? No. It simply had how many compounds in the question? 1. Okay? If you look at question 1 on the quiz, it said find the, look at it for a second. It said find the density of carbon dioxide. Carbon dioxide is how many compounds? 1. Number 2 said find the volume of nitrogen. Nitrogen is how many compounds? 1. They all work that way. But as you're writing that one, how many compounds are you seeing as you're writing?
2.
At least 2. Okay? So that should be your first clue that this question is different. Okay? That's going to involve stoichiometry. It's going to have a balanced equation. Yesterday you used words like, it says combustion as well. So if it said combustion, that's a stoichiometry word. What other words do you see up there that say it's got to be a stoichiometry problem? React. I heard something else. What? Produce. Okay? So when you see words like, my pen back out here. When you see words like produce, react, those things should scream to you, I am stoichiometry, and I will need a chemical reaction. Okay? Nothing you did on the quiz today, use those words. Nothing on the quiz 2 days ago, use those words. There were no words that said chemical reaction. Everything had the word gas. It may have told you the gas, but you didn't have to react the gas. Now, we have to write a balanced equation. Do we see how that is different? Okay. Now, do we remember how to write the balanced equation?
Sort of.
Sort of, okay? So produce means we write a what? We write a yield sign. All right, what did it say was produced in the question?
Water vapor.
All right, water vapor is just water. So what's the symbol for water? Okay. What does it say the water is produced from in the question? Hydrogen and what? All right. Now, the fact that they're gases, we can put the states in. We can write the little G's if you want. Do we have to write the G's?
No.
It's irrelevant for what we're doing. Now, when we write H plus O, what does everybody in here still remember we have to do? Put a 2 because they're diatomic. Okay? But if you want to write the little G's, you can write the little G's if it makes you happy. Do we need to know their G's? Do the G's make any difference to us when we write the equation? No. Okay? You can certainly write the states if it makes you happy. Okay? Now, we need to balance the equation. That's right. There's how many O's here? So we're going to put a 2 here like Diamond said to make 2 O's. We'd have how many H's do we make? So we're going to put a 2 there. Everybody remember doing the balancing? Okay. Comes back nice and easy. Now, this is what we were talking about yesterday. When you look at this question, do you see anything that tells you a temperature and a pressure? Nope. It says what? The same temperature and pressure. Because it says that, that means there are no formulas that are available to you. Absolutely none. Because it says same. Okay? Does everybody see that? Yeah. Can't use anything you used on the quiz today because there are no numbers given to you. So the only thing that you're left with is a what? T-chart. Very good, Alex. The only thing you could be left with is a T-chart. And then we're going to use the balanced equation over there that you guys said to fill it in. All right? So what number am I putting in my T-chart? What's the only number they gave me up here? 4.55 liters of what? Liters of oxygen. That goes on the top. So what has to go on the bottom? Liters of oxygen. Now, this is the point I was trying to make yesterday. Mole ratios are how we change compounds, right? So today we're just going to use something different. Instead of a mole ratio, we're going to use what's called a volume ratio. Instead of writing moles to moles, I'm going to write volume to volume. Okay? So, what compound am I trying to go to? Liters of hydrogen. So I'm going to change to liters of what compound? H2. Okay? Instead of writing mole to mole, I'm going to write liters to liters. I can do this because is my temperature or pressure changing in the question? No. What I tell you about being in a first-year class, it's not going to change. Okay? So you can always make that assumption. So when I fill in these numbers, what do I know about hydrogen and oxygen? The numbers come from where? Come from the coefficients. Volume ratios always come from the coefficients. So hydrogen has a what? And oxygen has a what? So we get what? 9.10? Questions? That's it. There's no catch.
How are you going to try and predict?
So I can give you a harder equation?
Oh, okay, here's the catch. So we're gonna have to remember any certain like equations with
What's ammonia?
NH3. That's it.
The other equations are on the reference table. All right, so let's say we work this way. Okay?
we doing this?
Yeah, don't write it down. Just let's solve it. You try it first. This is pretty straightforward. This is as tricky as it gets, only because you'll struggle with the equation. We did the equation, but people forget the equation. You can use your reference tables. Which is why
What are we using for reference?
blue chart.
No, but what are we using? Look at it. I'm not seeing why we have to use it. So.
In case you can't write the equation.
You talking about this stuff?
Yeah.
I don't think I knew that. It's not think I'm doing this wrong.
Thank you, my dear. You're just absent. Thank you for not getting a party.
Any notes?
No, you're chilling.
Oh, yeah. Wait, you can't have a decimal coefficient.
No. All right, so what's the equation? Goes to what? Are we okay with that?
No.
That's why I was asking. This is as tricky as it gets. And only because people struggle with the equation, not because you can't draw the T-chart. All right, so what kind of reaction is it? It's single replacement. Because it's on my desk.
This is the active metal with A from water, right?
Uh-huh.
Okay.
Most people look at it and they're like Caroline was. I don't need the blue chart, it's single replacement. So we look at it and we go, oh, okay. +1, +1, -2, and you get NaO plus hydrogen, and you get that. Okay, well, it's still wrong. But that's the one that I tried to tell you about when we were doing balanced equations. And it's the one that's the tricky one because a metal plus water doesn't make what you think it's going to make. Okay? So you got to look this one up on your reference table and get what it's supposed to do. A metal plus water is on your reference table. This is a metal. This is water. And so when you look it up, it actually makes metal hydroxide plus hydrogen. So if you just follow what it says on the reference table, it says MOH plus H2. So you can put Na with OH and then plus H2. And you can get rid of all that crap.
Okay.
So +1, -1, they cancel out, and then you're good to go.
So what would be a good way to like remember to look at like what's it?
It's a metal plus water. I'm not sure I got anything besides it's a metal plus water. And then to balance it, it's not balanced. So you've got 3 H's because you got 1 and you got 2. So that's 3. So what I tell you to do anytime you had an odd number, put a 2 there. So now we have 4. So we put a 2 there, make 4, 2 O's, 2 O's, 2 NA's, 2 NA's. That's as hard as it gets. And that's only because you forget the reaction. So what do I do now that I have the equation? Make the what?
Chart.
Make the chart. Okay, what goes on top?
15 liters of water.
All right, what goes on the bottom? Okay, what do I put on the top? Liters of hydrogen, because that's what I asked for. All right, where do the numbers come from? The balanced equations. So what's in front of hydrogen? What? 1. And in front of water? Yep. What's that going to give me? 7 point something? Now, if you get the information in milliliters, do you have to change it to liters? Let's just say this was milliliters for a second. Okay? If that was milliliters, this would just say milliliters to milliliters. You do not have to change it to liters. Okay? It can be done in milliliters too. Questions?
But you like to complicated. So are you ever gonna apply us to switch to?
Wait, so can you refresh me on the single from double displacement and all that?
Right now?
No, like I'm trying to remember, and I don't know how y'all came up with looking at that section.
Single displacement is an element plus a compound. Double displacement is two compounds. Synthesis is generally going to be an element plus an element, or like an element plus water. Well, let's say it's metal oxide plus water is what's on your reference table. Decomposition is just one compound with an arrow, and then combustion is a metal oxide plus or hydrocarbon plus oxygen.
And we use single displacement.
We use single displacement because it was an element plus water. It was a element plus a compound.
I have a whole question.
Yep.
It's not about this.
Yep.
Can I ask a question about this?
Uh-huh.
Okay. Which formula? Wait, no, that's the density. What is it?
No,
Two calculated volume of nitrogen.
Could we use which one? What?
You use PD or big M.
Wow, I think I use. Okay, it made me very upset because I think I used wrong formula first.
You can use PD or big M. You
Yeah,
use
I
either one.
used the wrong formula first, and then I got an answer.
Did you use density?
No, I
Then
didn't.
you use the right formula.
No, I
Like you
put
didn't use
formulas
density.
in the wrong place accidentally. And then I got a really big numbers. I had to redo the whole problem, and then I realized that.
Did you remember nitrogen's diatomic?
I forgot that at first, and then I realized actually it's
Okay.
Yeah, I did that too.
Okay.
I still don't think my answer's right, so.
All right. Last type of question we're going to do. We need to at least do a couple of these today before you leave. All right. Volume mass stoichiometry. Now, these are the ones that drive people crazy. There are two of these on the test. They're 10 points each. Holy crap. Because they combine. Sorry. Because they combine the three skills you've learned. PV equals nRT, volume ratios, writing balanced equations. Okay, all in the same question. For some of you, yes, it will. It'll kill you. Okay? Now, writing a balanced equation should not ask too much of you. You already know how to do that. Theoretically, we already know how to use PV equals nRT. So we're really just combining our volume ratio with what we already know how to do. Theoretically.
Theoretically.
Although based on the questions you just asked me about number 2, I'm beginning to wonder.
Oh, speaking of number 2, again, do you have to change that to then?
Depends on the formula. If you use PD equals nRT, yes. If not, no. If you use a formula with N, it has to be in moles. If you use a formula with M, it has to be in grams.
Okay,
So it depends on the formula you choose.
I use big M and then
Then it has to be in grams. If you choose moles with the N, it has to be in moles.
I don't know what I did with my life. Okay.
Okay, so it depends on the formula you chose.
What if you actually got a number like what you got in unit wrong?
Then it's -1.
What did I got wrong?
She asked if she got the answer right and the unit wrong. It's -1 like it's always been.
But how where did you go to change? Oh, good, I know. No, like you forget.
If you get the right answer at the end, it's -1. Now, if you plugged in everything right except you put grams in when it should have been moles in the problem, that's a standard deduction. That's probably -5 if everything else is right.
That's for these students.
Oh, for first period?
Yes, ma'am.
Oh, well, thank God. I'm going to get to give out some good grades today instead of fourth period grades. Woo! I'm glad I had that all F's. Y'all's first course for change. All right, write that problem down while I hand these things out, y'all.
I use big head.
Well, at least your mom would be happy with my grade when she sees math.
Oh, amen.
Don't look at mine, just look at my name.
This is all one of the perks of being a teacher.
What?
It did rise though from what it.
I think she needs
Oh no, I know the zero. I'm talking about the math as well.
Dang, you need to work on that math grade.
It's not my strong suit.
I just gotta go to the computer. This is just
It's not
easy.
even my fault that
Wow. Lewis, I thought my zero was bad.
You have to try. You actually have to try not to.
It's not yours.
I'm not.
I didn't work on that English grade there like that. Your definition of fine is not hard to say.
It's the one time you scared me.
Your grade is a little rusty there, my dear.
You're funny. You were funny watching people like that. I'm not ready. What'd you get?
Dang. Do you show up for internship?
Yes, I know that's mine now. Let me see it.
Dang, you don't even have to do her like that.
Oh no, it was not this yesterday. Oh, we might talk about big talk.
Big talk.
Yeah, messed up.
That's a 95. That's a 70.
What is your Okay.
I know you're silent because you
I'm out
need to.
here.
I know you saw it.
My chemistry grade is not that bad.
Yeah, it is. First quarter, you and second quarter.
It's fine.
Science grade sucks. I see that math grade. You showing up for
Hey, yo.
I'm just saying.
Where's it going?
All right, Wallace.
It can't go down.
What's your grade?
That's my fault. It's not my
Are
fault.
you a native speaker?
Yes!
How do you get that grade in Spanish class?
She can't read my name, so she gave me a 0.
Yes, I told her it was my name. She was like,
I can't read it, so I'm gonna give you a 0.
I got 112 on that test. I should have got the grade.
It's not my fault. It's not my fault. I want you to know that.
You're selling in chemistry. Get ready to say.
Yeah, you got-
Find you a work
I'll say
Oh my God.
And while you're facing
Dang! I'm ain't talking to you this time. You make Wallace look like a scholar in Spanish. I know you did.
And a 77.
Y'all must so fun.
Let's just see if I can pass it.
He's working on the chemistry. He may look at you doing it. Alright. So, moving on. Now that I've had my fun for the day. Woo, this almost got some. Now, how many grams of propane? So, when we do this, a lot of you are going to look at this question, and it's going to look exactly like it did on the quiz today. Okay? It says STP, it asks for grams, you got a volume. It looks very similar to question number 3 on the quiz. All right? What's different about this one than question 3? It says combustion. Okay? This one is different from question 3 because it uses the word combustion, it has propane, and it has CO2. Okay? There are 2 compounds. It says combustion. Okay? There's 3. That's true. I didn't even look beyond the 2. Okay? That tells you that this is a stoichiometry problem. Now, you have 2 options here. You can either use a mole ratio or a volume ratio. I do not care which one you use. Some of you are very bright and will naturally, because you're mathematically inclined, will figure out, oh, this wall, I could have done with that with a mole ratio. Yes, you can, and you may choose to do it that way. Because I'm teaching volume ratios, which one am I going to use? I'm going to teach it with the volume ratio. That does not mean it cannot be done with a mole ratio. So when you're working them and you figure it out, you're like, oh, could I have done that way? Yes, you can, and feel free to do it that way. Okay? Now, those of you who really hate chemistry and you're a Lolly's camp and hate the math, okay, same, okay. Stick to the volume ratio that I'm teaching. All right? For those of you who feel it a little more and can branch out a little more, feel free to try the mole ratio. Now, you can do these with big M. There are more steps. It's more complicated with big M. I'm not doing it with big M. I won't show you how to do it with big M. Again, those of you who are more math inclined and will figure it out on your own, knock yourselves out. If you do it that way on the test, I will follow your work. But I'm not teaching it that way in class, okay? Because it's more steps. The way I'm teaching it, we're doing a 2-step chart. If you do it with big M, you have a 4-step chart. Okay? That's why I don't teach it that way in class. Well, some of you will figure it out. What? We will. That's good. We are going to need it. All right. So when we look at what we know, what do we know in the question?
It has 5 liters.
Okay, 5 liters of CO2. I'm going to come back to that. That's why I wanted to ask that question. All right, what else do we know? 1 ATM. 273 Kelvin. All right. Now, coming back to what I said I wanted to talk about. We have, oops, that's too light, liters of carbon dioxide. What do they ask me to find? We need grams of propane. And normally, I would have the C3H8 in the question. I just forgot to type that. I would never expect you to know propane is C3H8. That's a typo on my part. Okay? Propane is C3H8. Now, if we have to change compounds, what must we write? Yes, so we're going to need a balanced equation here. Okay? So, how do we write combustion? Okay? Because I start in CO2 and I have to go to propane, I have to have a balanced equation. That's what tells me I need it. The question gave me carbon dioxide and I need propane. That's how I know. So when I look at my equation, is it balanced? Nope. I have how many C's? So I'm putting what here? I have how many H's? So I'm putting what here? Now, that's 6 and 4 makes, so I'm putting what here? Is everybody okay with our equation? It's the same one we actually wrote yesterday. So, I need to change my volume to propane. Okay? How do I do it? Set up the volume ratio. Okay? So I'm going to draw a T-chart. What goes on top? Liters of CO2. What goes on the top?
So the number you start with is always the one they give you the problem.
Yep. Where do the numbers come from? Okay. What's in front of propane? What's in front of CO2? Okay, I hear 3, I hear 5. One of those is right, one of them is not.
3.
Okay. So, 5 divided by 3, 1.75? I'm guessing. 1.6? Okay. All right, 1.66 liters, C3. I don't think I can fit that there. I'm going to back that up. All right, liter C3H8. All right, so now my problem is exactly what you guys have worked for the last 2 days.
Oh.
All I have left is, I won't say it because Ollie will get mad.
Wait, okay.
Look at you.
Sorry.
I wasn't going to say it. They did it. Okay?
Thank you.
So, PV equals NR and T. So what's my volume? 1.66. What's my pressure? What's my moles? I don't know. My R is 0.0821, of course. And my temperature is what? 273. So I'm going to find N. Now, this is what we were talking about a second ago. When you solve for N, what is N? It's moles. So this is why a minute ago when y'all were all asking me, did it have to be in moles, did it have to be in grams, what did it have to be in? When you solve for N, N is moles. Is it what I want for an answer? No. I wanted what? What I have to do? I got to change it into grams.
Grams, you mean grams of propane, right?
I mean grams of whatever they asked me for. What did they ask me to find? Grams of propane. So yes. So 1. And what on earth is the mass of propane? I think it's 44. 3 times 12 is 36 plus 8 is 44. Did I add wrong?
No.
Caroline's looking at me like I'm nuts.
No, I just trying to 3.263.
Okay, so I said C equals 3, H equals 8 times 12 times 1, 36, 8, 44.
What is that equals 3.26? Where is that?
That's what we got when we said this comes out. That's what Diamond told me it was. If she's wrong, then she's the one that got it wrong.
Wait for moles.
When we multiplied to get grams. I'm glad to know. I was just trusting her. So why didn't you get to 112?
It's because she couldn't read my name. My name was on it, you know, the name I always wanted.
So she just couldn't read it?
No. And it wasn't even that bad.
Oh.
Yeah, she did something like that. So, I know. I was mad. Like, she had it in back her test, and I was like, oh, I didn't get my test. I knew I took it. And she was like, Salma, you know, there's a test at the
So how do you write your name now?
the same way. That's not exactly. So because so I'm a part of the lady.
Yeah.
She was like, that's not.
I'm working on it. Backwards. That's what starts in grams and goes to volume. It's the complete opposite. It's flipped. I can run the equation for you.
You won't do that later, though. So you're like,
I even wrote one on the test.
Wow.
Oh my God.
I wrote one equation on the test.
oh.
Out of the three, I wrote one out of the three equations.
You should have wrote 3 out of 3.
And I feel like you wrote the easiest one.
She wrote
Trying to think which one I wrote.
What the heck is HCO?
I don't remember which one I wrote. I did write one though. But I remember that much, but I don't remember which one.
I remember what happened before we even got there. I remember they brought it in the like, I don't really like making fun of people that often, but she looks like, no, she looks like pretty much clown.
Y'all are cold.
I'm cold. I'm pretty much.
No, they're just mean. Excuse me, let me change the word. They're just mean.
Do I care? I want to. You can't honestly tell me that you love her. We won't tell. We all know.
You know, I've said this many times, and I will say it many, many, many more times before I retire. I can have all the internal conversation I want to have. I just can't.
Well, you
can mouth it though.
Pause the video.
So I will take.
Oh, well.
All right. So when you look at the question, again, we're doing PV equals N, R, and T. This time, we're solving for volume, right? So you're going to do your volume ratio at the end. Okay, because you don't have a volume to start with this time. So you're going to find it at the end. So what do we know? 745 torr, okay. 35 is T, good. 0.0821, and I need one more. I need the moles. 875 grams. All right, what is the grams of? All right, tungsten oxide. So which one of those is tungsten oxide? WO3. Okay, W is tungsten, so WO3 is tungsten oxide. All right, so 745, what do I divide by to get ATMs? 0.980 is correct. All right, 35 plus 273 is 308. All right, now we need to do these grams. grams to moles. 1. Tungsten is, I don't remember that one.
183.
Plus 3 times 16 to 31.85. Now, this is where I'm going to stop in moles because I want to do a volume-volume ratio. Okay? Now, those of you who like to change things up, you could actually just do a mole-mole ratio there, and you'd be finished changing your compounds.
What is the whole mass? The numbers.
Huh? 231.85. So 3.77 moles. All right, but if you wanted to go ahead and do your mole ratio there, you would be finished changing your compounds and done with your ratios. All right, but I'm not going to do that because I'm doing volume-volume. All right, so PV equals nRT. My pressure is 0.98. My volume, I don't know. My moles are 3.77, 0.0821, and my temperature is 308. Volume equals 3.77 times 0.0821 times 308 divide 0.98, 97.2. But this is liters of what? WO3, because I haven't changed anything yet. If I use my balanced equation, when you get to this point, ask yourself, you have an equation. Did you do anything with it? Have I?
No.
That should tell you you've made a mistake. If you get to this point and you've done absolutely nothing with it, that should tell you you've got errors.
Wait, so everything.
No, you're not done.
Okay.
Okay? You're getting, at this point, half your credit on the test. Out of a 10-point question, you're getting 5. Okay? You need the other 5. The other 5 comes from knowing and recognizing, oh, dang, I didn't change my compound yet. I have to change from WO3 into the hydrogen they asked me for. That's my T-chart. Changing from that. Where do those numbers come from? But Alex? It would. Say it loud enough I can hear you. Be brave. Yes, the equation. That's why I was trying to get you to say it loud enough. The coefficients, the equation, those are the right answers. So WO3 has a 1 and hydrogen has a 3. So when you multiply that together, what do you get? 291.6 liters of hydrogen. Questions? Your what? What is a brain made out of? Brain matter.
What's your middle name?
Mine? Lee.
Really?
Yeah, really?
I thought it would be like some kind of cool.
Mine.
All right, the first paper I'm giving you is on volume ratio. Be right back. 291.6 L. We needed one more.
Chris.
There we go. One more. All right. The 2 that I'm handing you to start with are required homework for the day we return.
Do you think we'll have school on Monday? We
Oh,
have to
I
do all
certainly
of it?
will.
I don't think so.
Unless every weather forecaster over does East Coast is wrong. And they could be. You know, they've been known to miss the mark before.
It's going
I
to
will be
be,
shocked if I see you before Thursday.
it's going to be 19 degrees. Monday morning.
I think we have the potential not to see each other all week. I want you to do all the problems. All the problems. On both pages. Don't move. Don't move.
I got it.
You got grab and go. So stop with that. I got to go.
I have to cook this.
Hold on. The third worksheet is the test review. Now, I'm giving it to you You may go after you have it. For my slow workers who tend to only get 5 questions done in class, because you are not going to get a ton of time, so you might want to get a head start. Okay? Enjoy the snow. Stay safe.